Hey, so in this video, we will see the linear regression, the term that he's been using in the machine learning a lot. And let's see what it is. So this is, you can assume that this is a basic model, machine learning model that you can step yourself into. So the very first model, we will keep it simple and try to do what is a linear regression. So it involves a bit of a math, but we will try to avoid it as much as we can because math is difficult for everyone, even if you're a genius. So what is linear regression? So the linear regression is a relation. You can call it a relation. But a relation between what? It is actually a relation between two variables, x and y. So what are these actual variables? So you can assume that this x can be anything which is numerical. Like for example, let's take salary. And we can assume that it has a $1,000, someone has $2,000, someone has $3,000, let's say. But the main idea is, what is y variable? So what we have to find in the linear regression is the relation of this x variable, which is salary in this case, with the y variable. So what is y? Let's say it's experience. Maybe someone have a 3 years of experience. This guy, let's say, have a 6 year of experience. This guy have a 7 year of experience. So this can be alternative. Like we can say that this is our x value and this is our y value. But the main thing is to watch here is what is the effect of one of them on the other one. What if my experience increase? So how much my salary will be increased? So that is what we are trying to do. And maybe if we just cut it and use the term y for this one and x for this one, and I will tell you why. So first of all, let's see the condition of our linear regression. So this is the one that we need to predict. We call it y hat, you can say. And what we have here is an equation, which is m, and then it's an x, and then it's a c. So let me define that and broke down this condition into very well. This is the amount of increase, which what we have, increase or decrease. We can say it increase or decrease. You can say it as in a, like the rate of inflation, you could say. This is actually the value. Which value? The x value, the number of experience. So I'll say, let's say 3. And this is the value which is called intercept. So what is intercept and why it is there? What if this value is 0? What if some guy have an experience of 0 years? So what is the base salary is going to be? So this is used when this condition gets to 0. So that is why this is the value that will be our new answer, which is right here. Okay, now the question is how to find M and C. How to find those two things, because these are the things that we need in accordance to find the linear regression. Because we already have an x. X is already there. You can see that experience is my x value. I could just plug in x into my condition like 6, 7, or whatever, and I will have the answer if I have the value of both of them. So how to find the value for these two? Let's see what we can do. If we move down, we have a little bit of maths. We have the condition for M, and then we have the condition which is for B. So in this one, we don't have B. We are referring B as of our C, which is an intercept. Okay, so this is a lot of math included into this one. So we'll try to avoid it and keep it simple as we can, because this is an era of coding, and then we'll try to do it by code. But let's just see it by an example. Let's say I have a graph. My drawing is not very good, so stick with me. Let's say I have a graph. This is my y-axis, and this is my salary. Okay, this is my x-axis, and this is my experience, let's say. Okay, and I have few of the lines here, sorry, and few of the lines here. Okay, and let's say it starts from obviously 0, but it's at 1, 2, then I have 3, then I have 4, then I have 5. Okay, so what is my value at 1 year of experience? I might have a somewhere point like here, and maybe we have a value which is like 20,000 here. We don't care. Then I must have a plot from there. If my value is 2, then I have somewhere salary on the here. Maybe it's like 40,000 here. Then if my value is 3 years, maybe my value here. And then we have here value 70,000 or something. So you can see that it is creating a straight line. So that is what we are trying to find, a straight line, the line that fit these scatters perfectly. Like you can see that these are the scatters plot, and we have a multiple dots. We can have dots here, 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 here. It's not like, it's not fixed that we have in a straight line yard, like all the values are in a straight line, and we have a linear regression with them, like a linear relation, that one value is increasing this value, so the other one also matching up. We don't have it like this. Maybe we have it somewhere here, or maybe the values are going from up to down. So this is what we have to find. We have to find a one straight line starting from 0 or whatever, maybe from the height, a one straight line that, in a simple word, I could say, occupy more of these scatter plots. So in future, if I try to say I have 17 years of experience, make a prediction for me. So my model will learn from this graph that what is the pattern that I'm following? Is my value going up, or is my value going down, or is it making some curves in the way? But we're trying to find the straight fit line that fits, and our model will learn it. So even if we have 17 down there somewhere, what we will do is to actually just have a plot here that line will be crossing it. If not, this is considered as an error, but don't try to world out this information with that, because we will try to see what's error is. You just need to say, what is linear regression? Is, in a simple word, we are trying to find a straight line which can contain more and more of these scatter points. And what are these scatter points? It's actually the value when we have 2 years of experience, what is the salary? 3 years of experience, what is the salary? These are just a point, the plot. Okay, so if I have a 17 years of experience, this. Now I have a model. I put 17 into my model, and that model will make a prediction. It will say, okay, if you have a 16 or 17 years of experience, you will have this much of a salary. And then it will give us a recommended predicted salary. And then we will see how good our model performs, how good it's accurate it is, how precise our model is. Then we will see for errors, but that's a later thing. But now we will use linear regression to find these two lines. When we find M, we find C. What we have to do is to just put X. And for X, we are putting 7. We have already learned the value of M. We have already learned the value of C. Now we just put 17 in there, and that will produce to our Y. And the Y is actually what? Our prediction. So stick with me to the next pod, and we will code it. And if you will have any doubts, we will clear it up. So stay with me, and the code will be really ease up the things for you. And we will try to keep it as simple as possible. So stick with me to the next part. Okay, so now what we will try to do is to actually use it into the code. And let's see how we can actually code the linear regression code. So for that, I will be using my CSV file, which I just downloaded from the internet. So let me just upload it here. And if you are trying to learn models and these kind of things, I guess you have to be familiar with this Google Colab interface. So that's the main step. So I'll just upload the file from here, which I found, the salary data. Okay, and all right, this warning is okay. Okay, so now I'll be using pandas to import and load this file. I'll just say like I need to import the pandas, so let's just quickly import it. It's PD. Okay, now what I need to do is to read that file. So for read that file, I'm going to call it a data, and I'm going to use pandas built-in function to read it. And that is why we're using panda, just to read CSV. And inside that, I have to give it the name of whatever my file name is with extension. So if I just run it, it gives me an error. What that error is saying, okay, so must be because of the S value that we have set. Yeah. Okay, let's rerun it. Okay, perfectly fine. Now let's see what's inside our data. So I'll be doing data.head real quick. And let's see the columns. Okay, so we got two columns. We got one column which is experience and the other one is the salary. So because I did just head, that is why it's only showing me the first 5 rows and not because this CSV only have 5 rows. It have multiple rows. Okay, so now what we need to do is to train our linear regression model. So we will try to use the pre-built model that is given to us by a Skylern library. So we will do that. We will not get into the maths, which is provided as built-in. Why not use that with the minimum code? Okay, so to do that, what I need to do is to import the model. So I will just quickly do that from sklearn.linear models. It will get into the linear models. Yes, here we go. Import linear regression. Here we go. So let me just run it. Perfectly fine. It just runs up. Okay. Now what I need to do is to create a variable in which I will initialize my model. I have imported it. So I'm going to say to it model. And then I'm just going to say linear regression. Yes. So now it will just load up and initialized my model. So now we are going to fit the data in. And from fitting, what does I mean by fitting the model? So what I'm going to do is to say model, and then I will say doing again, and then I will fit the data in it. From fitting, it means giving it to the data to train itself. So what I will give it to train itself, I have to give it to 2 things. The first thing is actually my experience column. This is going to be my values according to which I will make prediction. So you can say this experience values are actually my X value and the salary value is actually my Y value. So this is the difference between both. So the first we have to give the X values. So let me just give the X values. So because we're using a data frame, so we just need to give it like that, which we call our data. And inside those brackets, I just have to give the name. Yeah, the experience years. And for the next one, what I need to do is to just say data. And for the data, I have to give salary. All right. So when I will run this thing, that means that my model is being trained. Okay, giving us a little bit error. Okay, all right. So the error is actually nothing. The error is actually when we give the x-axis value, we just have to use the double brackets because it's a dimensionality thing. Don't worry about that. Okay, so half of our model is actually being trained. Now we only need to make a prediction. And how we can predict it? By using our variable of the model. So let's try to predict anything. But before predicting, let's try to see the coefficients. But we can do that later. Let's try to predict something. Okay, so I'll create a variable which is a experience, or I could just say exp, and which is I can say, okay, 10 years. That's pretty fine. I'll say 10. And now I will use the predict property on the model. So I will say model dot predict. And what I'm going to do inside that, I'm going to use the double brackets again, and I'm going to give it to my variable in it. And let's see how that runs out. Okay. The value runs out, and you can see it gave me an answer, and that answer is actually you can read it out, which is 1,20,909 and some decimal points. So if you have a 10 years of experience, my model is actually saying that you will have that much of a salary. So looking to that, if you have just a 1.2 years of experience, you will have some sort of that salary. So if I take and counter that, that means it's actually pretty good working. If I just humanly evaluate my model, so 10 years of experience and boom, 100K plus salary. Okay, so that is the thing that we do. But what if I have to do it manually? What if we talked about these things? Let me see. This equation, where is this M and B value that we said we will try to find using these formulas? So coming back, it is already being found for us. So how can we actually know these things? But we can use the predict. The predict is actually doing the same thing. But if you want to know what is your intercept value and what is your coefficient value, you can still find it. So for that, what you need to do is to just say model, which is my model. I'm using model because I named my linear regression this model. So what I need to do is to just say coef. Yeah, you can see it here. And just a second index, and here we go. So this is the value of actually my m, which I referred in the equation. And what if the value of c? The c, we say when our m or our x value, when our experience is 0. So this 0 will multiply with this m, as the condition is y equal to mx plus c. So we got the m right here. This is our m. So now we need to do c. What if this mx goes to 0? So the c will be our actual answer, the prediction, that y, that prediction that we did here. Okay, and let's try to do that. And for that, we just need to say intercept. So I'm just going to use model again, the keyword model. Not a keyword, this is actually a name of the variable. And I'll just have to say intercept, yeah. And yes, this is the type of my intercept. So to make sure that our this is actually the same, we're going to put it into the equation right in front of you. The equation I've told you is y mx plus c. So I'm going to do the same thing. I'm going to create a variable y. And for m, I'm going to use this value, as I said. And then I will multiply it by 10. And what is our 10? Is actually stored in this exp. So I'm going to store it in our exp. Okay, and then we have plus. And after that, we have c. So I'm going to use this. So let's see if that answer matched the exact answer of our prediction function that we use. Okay, that stored something in x. Let's try y. Let's try to print it. I hope that's the same. Yeah. So you can actually see not a single difference between them. It's actually pretty same that we did it manually using our equation, this equation, or we did it using the function which is provided as by Python library sklearn. So it's totally up to you. You can also find this m and this c using the formulas that we discussed. So it's totally up to you. So this is all from this side.